So, in line with the exercise, my goal in coming to Verge is to better understand our potential as a species in this place. Because it's been 50 years now since these images from space of Earth were first beamed back, thanks in large part to the amazing technologies of the space age. And these images, as many of you know, some of you were alive when these came back originally, right? They transformed perceptions of the planet. They gave a lot of people a taste of what it meant to actually think about Earth in an interconnected and interdependent kind of way. They were even credited widely with giving birth to, or at least accelerating, the current sustainability movement. Ironically, after decades of work from many people all over the world, including many people in this room, all of the Earth's major ecosystems are still in decline. Some of them are actually increasing in the rate of decline, which begs the question, what's going on? Why is this happening? And I'm sure that many of you in your darker moments quietly ask yourselves, are we doomed? 15 years ago, I started a company, co-founded a company, a design and engineering company that creates immersive visualization environments, specifically for visualizing planetary data. And through this, I've had the remarkable opportunity to work with scientists and artists and storytellers and engineers from across multiple different types of sectors. And we've been inquiring into the question of what is beyond sustainability. How do we regenerate the living systems of this planet? We've used satellite data from NASA, NOAA, ESA, JAXA, everywhere we can get it. We've developed interactive productions of local to global, actually cosmic to local to global kind of context setting for communities, particularly around the United States. We've worked with communities, companies, decision makers, and what we found is that the most important thing for people is to actually understand these global changes within their local context. They want to understand, what does all of this have to do with what's going on in my backyard and what's going on in my bioregion and how this is affecting my family. And through this, I've come to the conclusion that the biggest challenge that we face actually isn't the degradation of ecosystems. It's not even kind of the nature of the extractive economy. It's recognizing the invisible paradigms that shape how we think about all of this. So, for example, we think of CO2 when we think of climate change, right? Almost a one-to-one correlation. We know the story of sort of loading up the atmosphere, creating this blanket of heat, and it destabilizing ecosystems. But it's a two-way street. As the Buddhists say, it's mutually causal, that ecosystems also produce the environment, which also affects the climate at local and global scales. So when we look at satellite data, we really start to understand that land use, soil health, water cycles, biodiversity, animal migrations, human migrations, these are all part of the same integrated system. And it's actually critical that we start to consider it that way. But when we look at it in fragmented ways, it often leads to faulty, or at the very least, sort of incomplete assumptions about the nature of the system. So, quick pop quiz to kind of demonstrate that. What's the #1 greenhouse gas? Methane, methane. I heard somebody get it right. It's actually water, right? Easy to figure out if you think about it, because water vapor is an extraordinarily powerful force on the planet. And when we destroy ecosystems, we destroy local water cycles, which then start to disrupt global water cycles. And we have to have healthy soil, healthy land, healthy forest to actually stabilize and hydrate the landscape. And these also sequester carbon. So when we worked in Texas, we didn't even talk about climate change. It was kind of a hot-button issue. What we did was talk about local water cycles within a planetary context. We told the story of this remarkable project from a rancher named John Bunker Sands, who had a vision for using holistic land management practices to create a wetland. And now this is one of the largest constructed wetlands in the United States. And it's not only storing water and filtering water for the city of Dallas, and when I approached them, they didn't even know sort of what the equivalent ecosystem service cost was of what they were doing, and it turned out to be pretty remarkable. It's also managing flood risks and bringing back biodiversity. And in light of what's been happening recently, particularly in Houston, we understand how critical this is to get landscape management right. Here in California, we worked with local tribes to explore and understand and tell the story of their indigenous land management practices. Because this is pretty important, actually, because some data points to land management and the way that we misuse land is actually being, I think, 30% of the carbon emissions of the total budget of the planet. And counterintuitively, they have these traditional techniques where they use controlled burns to control forest fires. They actually use these to regenerate the soil, to regenerate local ecosystems. And it's so effective that the US Forest Service is beginning to adopt these and try this out in the context, particularly in California, of managing some of the brush fires around here. And I think that our job as technologists is to really understand these techniques for ecosystem regeneration around the world, and to understand how can we complement and support many of these more traditional techniques. A rather profound example is with global fisheries. Since 1950, we've had a tremendous expansion of fishing fleets, a tenfold expansion, actually, and 87% of species are either like stressed out or completely collapsed at this point. And 1% of the global fishing fleet is responsible for 50% of the catch. And at this point, by 2050, we're going to completely run out of seafood, right? And it's largely because no one's being held accountable for this overfishing. Well, a project called Global Fishing Watch is using satellite data and radio data to track these fishing fleets. They're making it available to the public. They're using machine learning and crowdsourcing to actually analyze the movement of these fleets over time, which says a lot about fishing activity. And for the first time, we actually have global transparency about global fishing fleets. And they're releasing this data and making it available to countries around the world that already have laws in place. Here you can see some of their protected fishing areas. And they're able to stop these fleets and start giving the ocean ecosystems a chance to rest and regenerate. This is absolutely essential. Similar technologies are being applied in the context of global forests. Since the beginning of human civilization, we've cut down half the trees in the world. It was recently estimated there were about 6 trillion before. We're down to 3 trillion, but we've got a net loss every year of about 10 billion trees, estimated around 48 football fields a minute. I'm sure you've heard these statistics. Well, to address this, a company called Biocarbon Engineering is actually using satellite data to map terrains and nutrient flows and biodiversity to come up with planning schemes that they can then feed into these quadcopter drones to create sort of automated planning systems. And their hope is that every year, using these technologies, they could plant up to 1 billion trees. And again, this is amazing technology, but we have to be mindful that there are other techniques that are actually more ancient that these could be supplementing and really supporting. Some of the better news I've heard recently is that India and Pakistan are at war, but they're actually at war to see who can plant the most trees. Right now, India's winning. In July of this year, I think it was 1.5 million people got together, and this was in the Madhya Pradesh province, which is where Bhopal is actually located. And in 12 hours, 1.5 million people planted 66 million trees. So that supplanted the record last year of 50 million. So it's remarkable what humans can actually do when they put their minds to it. And the Indian government has currently allocated over $6 billion to reforest 12% of the Indian subcontinent by the year 2030, right? I'm sure many of you have heard about the ecological civilization project going in China. They're 10 years into this now, which is really designed to embed ecological principles in every aspect of decision-making from the Chinese government. And these types of regenerative projects are happening around the world. I've been trying to map this global community of practice of people that are really trying to regenerate the health of ecosystems. And they're not just sequestering carbon. They're actually bringing back relationships. They're regenerating relationships. Because ecosystems, when they're healthy, have cascading benefits. They not only sequester carbon, they retain water, they provide food, they provide jobs, and perhaps most importantly, in this day and age, they reduce risk by actually increasing overall security. And I think that these projects are showing us that we as a species, humanity, can be a beneficial keystone species. We don't actually have to be doomed. But we have to evolve the way that we think about sustainability. That it's not just about sequestering carbon and increasing more energy efficiency, as critical as that is. we actually have to learn to be much better at collaborating with the most evolutionarily advanced technologies there are that we happen to call ecosystems. We didn't invent them, so we don't tend to think of them as technologies, but they are absolutely extraordinary in what they do. They've had a long time to work out the bugs, right? And we often just sort of ignorantly call them nature and take them for granted. But to do this, I think it's really critical that we start by regenerating the way that we think about our own potential to heal our relationship to the world and to each other. Thanks.